Good morning to everyone. I am Dr. Sumi MS. The name of the course is Electromagnetic Fields and today's lecture topic is Boundary Conditions. On completion, the students will be able to understand the continuities and discontinuities in fields in dissimilar media and also derive the boundary condition on the magnetic flux density at a smooth interface between two material regions. Boundary conditions on magnetic flux density. In homogeneous media, electromagnetic quantities vary smoothly and continuously. At an interface between dissimilar media, however, it is possible for the electromagnetic quantities to be discontinuous. Continuities and discontinuities in such fields can be described mathematically by some boundary conditions and used to constrain solutions for the fields away from these boundaries. We can derive the boundary condition on the magnetic flux density at a smooth interface between two material regions using the Gauss law for magnetic fields. As per Gauss law for magnetic fields, the closed surface integral over B ds is given as 0. Here S is any closed surface taking the form of cylinder centered at a point on the interface. The flat ends are parallel to the surface and are perpendicular to n cap. Thus, let the radius of the cylinder be A and length be 2h. From the Gauss law for magnetostatics, we shall write the closed surface integral over B ds is equal to integral over the top region B ds plus integral over the side area B ds plus integral over the bottom area B ds is equal to the summation of all the three integrals is equal to 0. Reducing h and a together while maintaining a constant ratio h by a is less than 1 and keeping the surface S centered on the interface. And as here h is very much lesser than a, the area of the side can be made negligible relative to the area on the top and the bottom areas. Thus, as h tends to 0, we shall write the top integral over B ds plus the bottom area integral over B ds summation is equal to tends to 0. As the area of the top and bottom sides become infinitesimal, the variation in the flux density over these areas will become negligible. Hence, B1 dot n cap del A plus B2 dot minus of n cap del A tends to 0, where B1 and B2 are the magnetic flux densities at the regions, interface regions 1 and 2 respectively, and del A is the area of the top and bottom sides. And here the orientation of the vector n is with respect to the region 1. Finally, we shall write n vector B1 tends to B cap, B1 minus B cap is equal to 0. The normal, that is the perpendicular component of magnetic flux density across the boundary between the two regions is continuous. And here, while B tends is equal to mu h, the normal component of magnetic field intensity across the boundary between the two material regions is observed to be discontinuous if the permeabilities are unequal. Quiz questions on boundary conditions. Derive the boundary condition on the magnetic flux density at a smooth interface between two material regions. How do the normal component of magnetic field intensity across the boundary between two material regions vary if the permeabilities are unequal? Thank you.